In the early hours of June 30th, 1908, a mysterious and monumental event unfolded in the remote Siberian wilderness near the Podkamennaya Tunguska River. This event, known as the Tunguska event or the Tunguska incident, was characterized by an explosion of immense magnitude, estimated to be around 12 megatons. The blast was so powerful that it flattened an estimated 80 million trees over an area of 2,150 square kilometers, creating a scene of utter devastation. The morning was like any other in the sparsely populated East Siberian taiga until, without warning, the sky was torn asunder. Eyewitnesses reported seeing a bluish light, almost as bright as the sun, streaking across the sky. This asteroid moved at a tremendous speed, leaving a thin glowing trail in its wake. As it neared the horizon, it transformed into a massive fireball, emitting a light so intense that it bathed the surrounding landscape in a surreal reddish glow. The serenity of the Siberian morning was shattered by a deafening explosion. The force of the blast was so immense that it produced a shockwave that knocked people off their feet and broke windows hundreds of kilometers away. The ground trembled and the air was filled with sounds of what many described as artillery fire. The Tunguska event is the largest impact on Earth since records began. Despite its magnitude, the event occurred over a sparsely populated area which limited human casualties. Eyewitness reports suggest that at least 3 people may have died as a result of the explosion. The explosion is generally attributed to a meteor airburst, the atmospheric explosion of a stony asteroid about 50 to 60 meters in size. The asteroid approached from the east-southeast at a high speed of 27 kilometers per second. The explosion registered at seismic stations across Eurasia, and airwaves from the blast were detected as far away as Germany, Denmark, Croatia, the United Kingdom, the Dutch East Indies, and even Washington, D.C. In the days following the event, night skies in Asia and Europe were aglow, likely due to light passing through high-altitude ice particles formed by the explosion. There were several testimonies from people who claimed to have witnessed the event. At breakfast time, I was sitting by the house at Vanavara trading post approximately 65 kilometers or 40 miles south of the explosion facing north. I suddenly saw that directly to the north, over Onkal's Tunguska Road, the sky split in two and fire appeared high and wide over the forest. The split in the sky grew larger and the entire northern side was covered with fire. At that moment I became so hot that I couldn't bear it, as if my shirt was on fire. From the northern side where the fire was came strong heat. I wanted to tear off my shirt and throw it down, but then the sky shut close and a strong thump sounded, and I was thrown a few meters. I lost my senses for a moment, but then my wife ran out and led me to the house. After that, such noise came, as if rocks were falling or cannons were firing. The earth shook, and when I was on the ground I pressed my head down, fearing rocks would smash it. When the sky opened, hot wind raced between the houses like from cannons, which left traces in the ground like pathways, and it damaged some crops. Later we saw that many windows were shattered, and in the barn a part of an iron lock snapped. Talk about terrifying, this testimony is a very accurate representation of what one would expect to experience during an asteroid impact. Imagine the dinosaurs who faced a wrath hundreds of times greater than this one. It's no wonder they perished at an extinction level. The Tunguska event is a mere shadow of what the dinosaurs experienced. Here's another testimony, published in a newspaper on the 13th of July in 1908. On the 17th, an unusual atmospheric event was observed. At 7:43, the noise akin to a strong wind was heard. Immediately afterward, a horrific thump sounded, followed by an earthquake that literally shook the buildings as if they were being hit by a large log or a heavy rock. The first thump was followed by a second and then a third. Then the interval between the first and the third thumps was accompanied by an unusual underground rattle, similar to a railway upon which dozens of trains are travelling at the same time. Afterward, for 5 to 6 minutes, an exact likeness of artillery fire was heard, 50 to 60 salvos in short, equal intervals, which got progressively weaker. After 1.5 to 2 minutes after one of the barrages, 6 more thumps were heard, like a cannon firing, but individual, loud and accompanied by tremors. The sky at the first sight appeared to be clear. There was no wind and no clouds. Upon closer inspection to the north, i.e. where most of the thumps were heard, a kind of ashen cloud was seen near the horizon, which kept getting smaller and more transparent, and possibly by around 2 to 3 PM completely disappeared. Scientific investigation into the Tunguska event has been extensive, but they all occurred long after the event transpired, with a deepened scientific inquiry occurring roughly a decade after the event. There have been an estimated 1,000 scholarly papers published, with most being in Russian. Because this occurred in 1908, there was limited instrumentation available, so scientists had to rely on eyewitness testimonies and assessments of what occurred. The first geological analysis took place more than a decade after the event, led by Russian mineralogist Leonid Kulik. Kulik's expeditions in the 1920s and 1930s found a zone where trees were scorched and devoid of branches but still standing upright. This led to the conclusion that the object exploded in the air rather than hitting the Earth's surface. Subsequent research has supported the airburst theory, meaning the asteroid blew up above the surface rather than impacting it. There have been findings of microscopic silicate and magnetite spheres in the soil and in the resin of the trees in the area, suggesting an extraterrestrial origin. Chemical analysis of peat bogs from the area also revealed anomalies consistent with an impact event, and spheres were found which contain high proportions of nickel relative to iron, further pointing to a probable meteorite impact. Trees more distant from the centre had been partly scorched and knocked down in a direction away from the centre, creating a large radial pattern of downed trees. The Tunguska event stands as one of the most mysterious and powerful natural events in recorded history. Its study has not only shed light on the potential dangers posed by near-Earth objects, but has also spurred advancements in our understanding of them. The event remains a topic of active research and debate, a puzzle that scientists continue to piece together more than a century later. Thanks for watching.
Over 1.8 billion years ago, a massive event occurred in our solar system. An asteroid about 10 to 15 kilometers, or 6 to 9 miles across, ended its journey through space in a dramatic collision with Earth. This impact created what we now know as the Sudbury Basin in Ontario, Canada, turning it into a geological marvel. This ancient event laid the groundwork for one of the world's most affluent mineral areas. Today we're going to explore this fascinating chapter of Earth's history, from the catastrophic impact to its influence on the land's geology, and how the remnants of this ancient asteroid continue to shape our world and society. And as usual, you can also find this in article form on my website OzGeographics.com, or follow the direct link in the description. Join us as we travel back in time to uncover the transformative power of this event. The asteroid's approach would have been a spectacle in the sky, visible for days or weeks before the impact. The asteroid's entry into the Earth's atmosphere would have created a brilliant fireball, lighting the sky with an intense glow. Life existed in its most basic forms, but if observers on the ground did exist back then, they might have seen a bright streak across the sky as the asteroid hurtled towards its collision point. As previously mentioned, the asteroid, which was around 10 to 15 kilometers or 6 to 9 miles in diameter, collided with Earth during the Paleoproterozoic era, some 1.8 billion years ago. The impact site, now known as the Sudbury Basin, was transformed into a fiery cauldron, a temporary lava lake with temperatures high enough to melt rock. The original crater was estimated to be around 250 kilometers or 155 miles in diameter, a vast wound on the Earth's surface. Today, the basin measures approximately 60 by 30 kilometers or 37 by 18.6 miles. The impact created multiple rings, a feature often found in large impact craters on moons and planets throughout our solar system. I made a video on some of the largest impact craters that exist in our solar system, and many of them had this multiple ring feature. The force of the collision would have been felt far and wide. In fact, it would have been felt planet-wide, with shockwaves radiating outwards, destroying everything in their wake. And the earthquake that was produced would have been one of the largest that have ever occurred in our planet's history. The moment of impact would have been cataclysmic. The ground would have shaken violently, and a massive explosion would have sent debris flying for hundreds of kilometers. The heat and pressure would have been so intense that rocks melted, and the landscape was, obviously, forever altered. A shockwave would have spread out from the impact site, creating tsunamis in any nearby bodies of water. The sky would have been filled with dust and debris, blocking the sun and creating a temporary quote-unquote impact winter. One of the most harrowing consequences of an enormous asteroid impact is the phenomenon that occurs as ejected debris re-enters the Earth's atmosphere. This debris, travelling at incredible speeds, superheats the atmosphere within minutes or even seconds. The temperatures can soar to levels higher than the surface of the sun, reaching several thousand degrees Celsius. This isn't a slow or localized event, it's an instantaneous global catastrophe. The entire planet becomes engulfed in a searing heat wave. This intense heat would literally sterilize everything. After the impact, a central uplift dome remained. This occurred when the Earth's crust, compressed by the force of the impact, bounces back, creating a dome-like structure in the crater's centre. This dome is a characteristic feature of large impact events and is still visible in the Sudbury Basin. The surrounding area would have experienced significant geological changes, including faulting, folding, and the creation of new metamorphic rock formations. The landscape would have been scarred and reshaped, with pristine mountains, valleys, and lakes forming due to the immense forces unleashed. Now, an interesting process unfolded as the Earth began to recover from this event. The intense heat from the impact melted a large part of the Earth's crust, creating a pool of molten rock and metal. As it cooled, heavier elements like nickel, platinum, gold, and copper sank, while lighter minerals floated to the top. This process, known as magmatic differentiation, led to the formation of concentrated metal deposits that exist in layers, which is a dream for someone like me, who loves this kind of stuff. Over time, these deposits became part of the Sudbury Igneous Complex, now the world's largest source of magmatic nickel. More than $1 billion worth of metal ores are extracted each year from this region. The complex comprises several types of rocks, including norite, quartz gabbro, and granophyre. Now, we've already made a video on the largest impact site on Earth, which is located in South Africa, link to that in the description below, and this underwent a similar mineralization process, and as a result of this massive asteroid impact, which occurred only 200 million years before this one, led to the formation of the world's largest gold deposits. The story of the Sudbury Basin is a vivid reminder of these types of catastrophic events. And even though it occurred billions of years ago, it still continues to shape our world and society in significant ways. From the chaos of an ancient asteroid impact, valuable resources were formed. Resources that have fueled human progress for centuries. Thank you for joining us on this exploration of one of Earth's most intriguing geological events. The Sudbury Basin's story is a testament to the interconnectedness of our universe and the enduring influence of space events on our daily lives. Thanks for watching.
In the heart of Sweden, a colossal scar lies hidden beneath forests and lakes. The Siljan Ring, a testament to a cataclysmic event from 377 million years ago. This ring tells a story of a time when the Earth was very different. During the late Devonian period, our planet was experiencing an evolutionary explosion. In the oceans, early sharks swam alongside armoured fish and corals, while on land, the first forests were emerging, and primitive amphibians began their tentative steps away from water. But amidst this burst of life, a dramatic event was about to unfold. A massive asteroid hurtling through space set its sights on Earth, colliding with what is now central Sweden. It unleashed a force so immense that it reshaped the landscape. Powerful shockwaves radiated outwards, levelling ancient forests and causing the ground to upheave. The intense heat set the world ablaze, and where the asteroid met the sea, gigantic tsunamis surged forth. In this video, we'll take a look at Europe's largest impact site. You can find the article version, as usual, on our website by using a link in the description or by visiting OzGeographics.com. During the Devonian, the world was experiencing an explosion of biodiversity. However, in the vast expanse of the universe, an asteroid, a gargantuan chunk of rock and metal, was hurtling towards our blue planet. Its trajectory was set, and a region that would one day be known as Sweden lay in its path. The Earth was a vastly different place back then. Vast seas stretched across the horizon, painting a blue canvas brimming with life. Early sharks with their primitive forms navigated the waters, whilst armoured fish glided through the ancient coral reefs. Above the water's surface, the first whispers of forests began to emerge. Primitive plants like lycopods and ferns danced with the wind, casting their shadows upon the nascent land. Amidst this backdrop of burgeoning life, an ominous shadow loomed. Days became a countdown, and the serene region destined to become Sweden was blissfully unaware of the celestial juggernaut hurtling toward it. When the day arrived, it was cataclysmic. The sky was pierced by the asteroid, and in a heartbeat, the land met with the fury of the cosmos. With a blinding flash and a deafening roar, the asteroid slammed into the Earth. The ground trembled with unimaginable force, sending shockwaves that tore through the landscape. The skies turned into an inferno, with fragments from the impact site being catapulted upwards only to rain down as molten projectiles. Forests were flattened in an instant, and the skies were set ablaze with the fiery fragments ejected from the impact site. The once tranquil seas were no refuge either. As the asteroid met the shallow marine environment, it birthed gargantuan tsunamis, waves of such magnitude that they dwarfed anything in living memory. These watery giants raced with abandon, consuming and reshaping everything in their path. In the wake of such devastation, the world was transformed. Where the asteroid had struck, a vast chasm, the Siljan ring, marked the point of contact. The world was plunged into darkness as dust and debris, thrown up by the impact, shrouded the sun, obscuring it and casting the Earth into a twilight gloom. Temperatures plummeted, and what was once a thriving ecosystem now faced a chilling quote-unquote impact winter, turning once fertile lands into frigid wastelands. The rains that followed were no ordinary showers. Laden with chemicals birthed from the fire and fury of the impact, they were potentially acidic, scalding the land and further challenging the resilience of the surviving life. Over time, life began to adapt and reclaim the scarred land. The very heart of the impact, the crater, slowly filled with water, giving birth to what we now know as Lake Siljan. This new aquatic haven became home to a myriad of species, each carving out an existence in the shadow of this cataclysmic event. In the deeper recesses of the crater, the intense heat and pressure from the asteroid's touch transformed the Earth's minerals. Shocked quartz, bearing the unique fingerprints of the impact, crystallized amidst the ruins. Deep fractures in the Earth whispered tales of potential oil and gas deposits, legacies of the asteroid's fiery embrace. The Siljan ring, with its ancient scars and tales of cosmic fury, stands as a profound testament to the fragility and resilience of our planet. From the tranquil days of the late Devonian to the cataclysm that reshaped a region and onto the slow march of recovery, this story is a vivid reminder of Earth's ever-evolving narrative. It teaches us that even in the face of overwhelming adversity, life finds a way to endure, adapt, and thrive. As we reflect upon this monumental chapter in our planet's history, we are reminded of the intricate dance between chaos and order, destruction and renewal. The Siljan ring is not just a geological marvel, it's a symbol of the indomitable spirit of life and the timeless saga of Earth's journey through the cosmos. Thanks for watching. In the vast tapestry of Earth's history, few events rival the drama and magnitude of cosmic impacts. These cataclysmic occurrences have not only shaped our planet's landscape, but have also played pivotal roles in the evolution of life itself. One such event, both devastating and transformative, occurred beneath what we now know as the Chesapeake Bay. The actual formation of the bay can be attributed to this ancient impact. But the crater is no longer visible in the present day. It's been heavily obscured by preceding sedimentary deposits. These deposits are what led to the discovery of this impact to begin with, as oil is often found within sedimentary basins, meaning this event lay shrouded from human knowledge until as recently as the 1980s. Shocked quartz and shatter cones are present in the rocks. These two features only occur from large bolide impacts or large nuclear explosions, leaving an imprint of the vast forces produced by these events behind in the rocks. So in this video we'll take a look at the asteroid impact that shaped modern-day Chesapeake Bay in North America. To truly grasp the significance of the Chesapeake Bay impact crater, we must journey back to the late Eocene epoch, approximately 35.5 million years ago. The world was a different place then. Lush tropical rainforests covered the eastern coast of North America, and the waters teemed with marine life, leaving behind dense layers of lime from their microscopic shells after they died. During this era, a massive bolide, perhaps a rogue asteroid or a wayward comet, set its sights on Earth. Hurtling through the vastness of space, it travelled at a mind-boggling speed of about 111 miles or 179 kilometers per second. Its destination, the eastern shore of North America. The collision was nothing short of cataclysmic. As the bolide made contact, it unleashed an energy so immense that it vaporized upon impact, fracturing the granite continental basement rock to depths of nearly 5 miles or 8 kilometers. The immediate vicinity was transformed into a deep crater, surrounded by a terrace-like ring.
This depression, which initially spanned about 25 miles or 40 kilometers, eventually expanded to its present diameter of 53 miles or 85 kilometers due to the sedimentary walls slumping inwards. The aftermath was equally dramatic. A mega tsunami birthed from the impact's sheer force raced across the land, reaching locations as distant as the Blue Mountains. For a brief moment in geological time, chaos reigned. Over the ensuing millennia, the raw scars of this cosmic collision began to heal. The crater, with its sedimentary walls and massive blocks, played a pivotal role in shaping Chesapeake Bay's topography. The continual shifting of the rubble influenced the flow of rivers, determining the bay's unique contours and waterways. Yet the crater's influence wasn't limited to the bay's formation. The impact had profound implications for the region's water resources. The cataclysm disrupted the area's aquifers, layering freshwater sources above the remnants of ancient salty North Atlantic seawater. This juxtaposition has rendered the lower Chesapeake Bay area vulnerable to groundwater contamination, a pressing concern for its modern inhabitants. For eons, the Chesapeake Bay impact crater lay hidden, its existence unbeknownst to the world. It was only in the latter part of the 20th century that its secrets began to unravel. In 1983, a drilling core off Atlantic City unveiled tektites and shocked quartz grains, telltale signs of a bolide impact. A decade later, oil exploration data painted a clearer picture, revealing the crater's full extent and significance. Today, the Chesapeake Bay stands as a testament to nature's dual character, its capacity for destruction and its ability to rejuvenate. As visitors gaze upon its tranquil waters, few realize the dynamic forces that birthed this magnificent landscape. Beneath its calm exterior lies a tale of cosmic collisions, geological marvels, and Earth's incredible resilience. The story of the Chesapeake Bay impact crater serves as a poignant reminder of our planet's ever-evolving nature. It underscores the importance of understanding our past to navigate our future, especially as we grapple with modern challenges like groundwater contamination. In the grand narrative of Earth's history, the Chesapeake Bay impact crater is but a single chapter, yet it's a chapter that encapsulates the awe-inspiring interplay of cosmic events and Earth's enduring spirit. Thanks for watching.